Okay, this is the final setup for the project. So we have one Arduino here. We're just connected to one wireless transceiver. I'll have this connected to one computer. And then we have the other Arduino connected to the LCD screen, the keypad, the wireless transceiver, and the RFID tag reader. So you'll see this is, whole complicated jumble here. I think I have pretty much everything except one pin, like A0, is being used on this Arduino here. So we have the pins from the LCD screen. We're using A4 and A5 as the data pins for the I2C communication. And this is connected to 5 volts and in ground. So here on the breadboard, we have the ground running here. We're gonna use the 3.3 volts as the power rail here on the breadboard because the wireless transceiver and the RFID tag both use 3.3 volts. So since both the RFID tag and the RFL 24L01 use SPI communication, they both need to share the SPI bus. So you can see here, I have these pins here in the middle, if you can see them, all going to pins 11, 12, and 13 on the Arduino. And then those are also going to the appropriate pins on the wireless transceiver and the RFID tag. So I'll include a pinout so you can see exactly how everything is connected on here. But it's a little crazy. So we have the keypad going into pins 2 through 9 like we normally did. Pins 11, 12, and 13 are for SPI communication. Pin 10 is, what is that connected to? That's connected to the SDA port on the RFID tag. And pin A1 is connected to the RST port on the RFID tag. Like I said before, A4 and 5 are connected to the I2C LCD. And then I am using pins A2 and A3 for the wireless transceiver, and then also the SPI communication bus. So like I said before, I'll put a pin out so you see how everything works, but that's how it is. So I'm going to connect these to the two computers, and I'll show you how it runs. Okay, before we get into the code, I want to just go through this flowchart with you, which will better help you understand the code. If you understand this, going through the code will be a lot easier. Okay, there's 3 variables to keep your eye on. First, we have the check variable. So if check is equal to 0, we're going to be looking for RFID input. If check is equal to 1, we're going to be looking for keypad input. If it's equal to anything else, we're just going to be skipping over that. We have the verify RFID variable. If it's equal to 1, then we're going to send the RFID tag value to the Arduino and then wait for the response. Then we have the verify pass variable. If that's equal to 1, we're going to send the keypad password variable and then wait for a response. So let's look at the flowchart of how the program works, and then we'll look at the code. So the program starts with everything set to 0. So if check is equal to 0, we're just waiting for RFID input. If we don't get any input, it just keeps looping back. If we do get an input, we're going to set check equal to 2 so that I can skip over looking for input, and then we're going to set verify RFID equal to 1. So at this point, we're going to send the RFID tag value over to the Arduino. And so we bring this down here. Now we're waiting for the response from the other Arduino. We get back a confirmation. If the confirmation is good, then we're going to set check equal to 1 so that the next time the loop goes around, we're going to start looking for keypad values. If the confirmation isn't good, we set check back equal to 0 and RFID back equal to 0, so we start back over at the beginning. So let's assume we have a good confirmation. So that means the RFID tag is correct. That brings us to here. Now we're going to be, when check is equal to 1, we're waiting for keypad input. So once the keypad, we keep getting keypad input until we hit the star key, and that submits the password. So once the password is submitted, you see how, so as long as it's not submitted, it just keeps going back. Once the password is submitted, we set verify pass to 1. So at this point, we're going to send the password to the other Arduino. Now we're just waiting for a confirmation back from the other Arduino. If the confirmation is good, then we open a lock. If the confirmation is not good, we set verify pass back equal to 0. And since check is still equal to 1, we're back here. We're just waiting on the correct password. And that's pretty much how the program works. So let me show you how that looks in code. Okay, so here is the code for the program. So we have all our library imports. We don't need the password library in this one just because all we're doing is getting the value, and then we're going to send it to the Arduino. So we won't be actually doing any verification on this side. So I took that out. So we have the keypad, we have the wire, liquid crystal, SPI, the RFID library, and the wireless transceiver library, the NRF24L01 library. So I've already shown you how we have everything set up. So these are the 2 configurable pins for the RFID module, and these are 2 configurable pins for the NRF24L01 module. We're going to declare our objects, one for the radio, one for the RFID, one for the LCD. See, I commented out the password since we're no longer using it. And here we have some variables. These are just some variables that I'm going to use to help me send and receive messages. Because one thing you can't do is you can't send a string over. You can't send a string easily just as a string variable over wirelessly between Arduinos. So it has to be a character array. So these variables pretty much are just going to help me convert strings to character arrays, so it's easier for me to send them. But we'll get into that when we actually do it. So here's everything for the keypad, and here is all the variables. I don't actually have an LED connected, but that would represent the lock. So if we decide to use a lock or something, or you use a light to distinguish when the door opened, you could connect the LED on A0, since it's the last pin we have, and you could use that to act as the lock or the light. So then we have our check variable, the verify RFID variable, and the verify password variable. All those start at 0. Our keypad object, this had to be defined a little bit further down just because the row pins, column pins, rows and columns hadn't been defined yet. Okay, here. So you've seen all this before in the getting started code for the radio. But so radio is equal to 0 here. That pretty much, when you have two radios, you have to set one up as the, I want to say sender and receiver, but that's, I mean, they're both sending and receiving, but they have to have opposite addresses. So, and there's some code down here that's going to distinguish the address between based on the radio number. So that's why that's set here. And also the row number. Actually, the row number, I could comment this out. This is actually not needed. This is if you were actually sending or receiving exclusively. So that actually doesn't need to be in here. So back in the setup function, we set up our keypad event listener. So you've seen most of this before. Just going to go through it. Set up serial port. SPI, initialize that, initialize the RFID, initialize the LCD, started with scan card. Set up the radio for everything we need here, and we set up the pipe channels for the radio. So depending on the radio number, so one's gonna have one set of addresses, the other one's gonna have the other. This is just our RFID helper function that you've seen in the previous video. And this is just an open lock function. And like once we actually get to the open lock, you can make this do whatever. Pretty much I just started over at this point. I have it say open sesame on the LCD screen, and then I set everything back to 0 so that we can do it all over again if we choose to. So let's get into the meat of the program. So just like the flowchart I showed you before, we start off with check is equal to 0, and we're just waiting for an RFID to be scanned. So that's what all this is, and you've seen this in the previous video. This is exactly how it works. So once the RFID once we actually get a value for RFID tag, then I have you'll see throughout the code, there's a bunch of times where I actually use the serial monitor for debugging. Sometimes I have them in there, sometimes I've commented out, but the serial monitor is definitely your friend, especially when you're going through this code. There's a lot of things little things you might miss. So I use a serial monitor for debugging a lot. So once we do get a RFID tag value, I just have it print out send, because that's what we're about to do. We're going to send this value over to the other Arduino with the radio.write function. So we send this value over, and like I said before, one thing I need to go up to. So the value that we get here is a string. So we get this value of a string. So we go up to this helper function here. We need to turn this to a character array, which we use the 2-character array method on the string, and we put it into UID. So now we're going to send out actually UID. So we turn that string into a character array, and that's what we're actually sending over. And then we're going to change verify RFID to 1. We have check equal to 2, and then we're going to have this radio start listening again, because you have to start and stop the radio so that you can properly do your transmitting. So it wasn't listening now it's going to start listening so that we can wait to hear back from the other radio. So going back through the loop function again, we have check is equal to 2, so it's going to skip both of these and go to RFID is equal to 1. Here I set up this verification character array that we're just going to use to dump the information we get back from the other Arduino. So, and I'll go over the code after this that is on other Arduino. So pretty much what's happening over there is it's getting the information, it's checking it based on whether or not that tag is good, and it's sending back good or bad. So I'm dumping this information, I'm getting it back now. So if the value we get back is set to good, and we use the string compare here to figure out whether or not it's equal to good. So in string compare, if that value is equal to 0, that means it's an exact match. So if the value actually is equal to good, then we set check equal to 1. I'm going to clear the LCD screen, put enter password on there, and set verify RFID equal to 0, so that the next time we go through the loop, the first thing it'll hit is this check equal to 1, which means it's going to just be waiting for keypad input. So just like we've done with the keypad before. No, actually, well, let me take a step back. Before, so if the RFID value is incorrect, we got back, then we set check equal to 0, verify RFID equal to 0, show incorrect card, and then scan card, and it starts all back over. So assuming we have the correct RFID value here, we're going to set check equal to 1, and now we're just waiting for keypad input. And that just uses the keypad event listener like you've seen before in previous videos. So let's go down to the keypad event listener function. Where is it at? Right here. Yeah, right here. Okay, so it's pretty simple. It's the same one we used before, except I changed up a few things. So it's waiting on a button to be pressed. If a button is pressed, it's printed to the LCD screen. And by default, if the button isn't either a star or a pound, then it's just going to add it to the current password guess. So since we're no longer using the password library, I just have to write some functions myself that pretty much do the exact same thing, but for what we need. So by default, it's going to add So password is a function is a variable we define. It's just a string, and by default, it's just going to concatenate whatever the button press to the current string. If the pound is pressed, we're going to reset the password, which you can see in this. You can see down here. So we just set pass just equal to nothing, pretty much. We're going to reset it. We're going to clear it, clear the LCD screen, put enter password back in there again. This was just some information I used for troubleshooting on the serial monitor. So if the button press is actually the star key, then if the button press is the star key, then we know that they're submitting the password. So I have this function send password. Or in here, I define the variable send pass. This is the character array we're going to use to send the information over to the other Arduino. So in here, this is just for troubleshooting here, so you can ignore this for now. So I'm going to clear the screen. So what am I doing here? So send password. Okay, I see what I did. I just cleared the screen out in case the password was incorrect. I didn't need to do it here, but I did it here. So I cleared the screen out. Just put enter password again, and we changed this password to a character array, send pass, and then we send it over to the other Arduino, and we set verify pass is equal to 1, which means when we go back to the loop function, we're going to be waiting for the verification of the password. So let's go up to there. Verify pass is pretty much the exact same as the verify RFID, except a couple different variables. So we're just waiting. We start the radio listening again. And if I didn't show you before, there's actually some stop listening. We have to actually stop the radio from listening when where is it at? Where's it at? Start listening. Okay, that's the beginning. So sorry about that. I'm going on a tangent here. So that's one time we stop it from listening. So you just have to remember that when you start the radio listening, if you want to be able to send things again, you have to stop it. So here we go. So verify pass. We stop it listening here, and then we stop it listening here in the verify RFID. So back to where I was. So verify pass equals 1. We started listening. We set this character array variable. We wait for information from the other Arduino, and we compare that variable to good. If it's good, then we set the LCD to open sesame, and then we open the lock. If it's not, we set verify pass back to 1, and we just wait for the next attempt to enter the password. So I know I went through that a little bit fast, but just go back through the video. The biggest thing, like I said before, is to understand that flowchart. If you understand the flowchart, then it makes it a lot simple. So let me go ahead and show you the other side of the code, which is a lot simpler. Okay, so this is the code for the other Arduino, and all that one has connected is the NRF24LO1 module. So like I said, this one's a lot simpler. You see here where we actually declared, this is the actual tag ID for a acceptable RFID tag, and this is our password. So this is just a character array. These are two character arrays we use for comparison's sake when we dump the value from the transceiver module, and also use this variable check just like I did in the previous one. Check equals 0, we're checking for RFID. Check equals 1, we're checking for keypad. So everything else is exactly the same as far as setting up the transceiver module itself. So let's go down to the loop function. So here we have check equals 0. We're just gonna wait while the radio is available. We're gonna wait till we actually get input. Once we get input, we're going to. Once we get input, we're going to. Oh, let me explain this function here. So, since we don't know the actual size of the information coming through, we use this get dynamic payload size method from the radio in order to get the length of it. And then we actually can declare a character array variable of that length. So and that's what I do here. So now we read the message, we put it into the variable we just declared, and then we do a string copy. So I'm going to copy into this RFID variable the information we just got from the radio. So then we stop the radio from listening, and then I'm going to compare this string to the get RFID value. So if this is equal to 0, that means everything's exactly right. Then this is something I use for testing here. I just print out on a serial mounted good card. So if that's the case, and I hit check equals to 1, so that the next time this goes through, it starts looking for keypad variables, keypad input, and then I just send back to the other radio good. So that, and then you've seen how I check that against what we did in the first program, and then we go to check equals 1, and we do the exact same thing with the keypad password. We get the value, we copy the value, and then we compare the value. If it's correct, we get good. If not, we send bad. And that is that one. So that one's pretty straightforward. So let me show you again how that all looks. So I have both Arduinos connected to 2 separate computers. So pretty much this is how it's going to work. So I have this RFID tag here. This is the correct RFID tag. Let me grab an incorrect one so I can show you that one as well. Where did I put it? Oh, there it goes. So this one here will not work. So this is a display here, scan the card. So the way this works is I'm going to scan the card. The RFID tag module is going to read it. Then it's going to send the tag ID to the other Arduino where the list of acceptable tags are located. That Arduino is going to send back whether or not this was a good tag. If it was, it's going to allow me to then enter the appropriate password on the keypad. If it wasn't, it'll just say incorrect card, and I'll have to keep scanning. And then it'll do the exact same thing for the password for the keypad. If I put the right password in, then the system opens up. If not, I have to, put the correct password in, or keep putting the password in until it's correct. So let's test it out. So this is the wrong one here. Incorrect card. Incorrect card. Let's put the right one in here. Enter password. So the password is 1234. Let's go ahead and try an incorrect password. And the star key is to confirm the password. Incorrect password. Let's enter the right one. 1, 2, 3, 4. See, that did go back to the next line, so something I have to fix in the code. But enter, open sesame, boom, and we're good to go. And then the whole thing will start back over. So that's it, guys. I hope you learned a lot. I've linked all the libraries and any references I used, as well as any diagrams or anything like that I showed you. So if you want to get the parts in this kit, there's a link below. You can get 30% off the store for all the parts in this kit. So until next time, talk to you later. Peace.